So hopefully you can do a little bit, you can go a little bit quicker on this one. So the vector from A to B would be the jump of A to B. So I think you all can do that. And you get 3, 4, minus 6. So if you're not sure how to get those, just pause the video and A to B, 0 to 3, 1 to 5, and 8 back to 2. Write down the vector equation. It's the same thing as question 4. So pick a point. Doesn't matter which one, you'll get marks. Either one, I'll pick this one, I think that was 8. And plus some parameter times 3, 4, minus 6. That's the form of vector equation. This is the direction it's going, and this is like a starting point for it, or a point on the line, not a starting point. Okay, that's part A. Part B then. Second line L has this equation. Given that something's perpendicular, so it's again perpendicular, scalar product will be equal to 0. So, of the vector. So this is the one vector. Looking at the other equation, the vector of line 2 is P0 and 1. So this scalar product times that is equal to 0. So multiply the top by the top, the I by I, so 3 times P plus 0 times 4 plus minus 6 times 1 equals 0. Working all that out, you get 3P is equal to 6. So 3P is equal to, minus 6, and then 3P is equal to 6P minus 2, which is what we wanted. Much celebration. Part C then, lines 1 and 2 intersect at a point. That means that point is on one of those lines, or both those lines. That means it will just satisfy the line. So you can take your vector equation of either line, so L1 or L2. Let's use L1 since we have it here already. So we put the vector here, or the point here. 9, 13, Z will have to satisfy this thing. 0, 1, 8 plus T times 3, 4, minus 6. Will have to satisfy that, and that'll have to be the point on the line. Now we don't know T or Z, but we have enough information to find both. For instance, I can find T pretty early because 9 is equal to 0 plus T times 3. Just from the I's line, the X parameter. So T then would be 3 from that. That's great, which will help us when we go to the last line. Z is equal to 8 plus T times minus 6. So Z is equal to 8 plus, now I know T is 3, so it's now 3 times minus 6. Z then equals 8 minus 18, which is minus 10. So you could have used the other line and you would get the same results. I think most people overcomplicated that in the exam. Unit vector, I don't know if anyone got this right, maybe one. So now we have L2's vector from the question is, well, it was P01, but we found P to be 2, so it's 201. 201 is the vector, but that's not a unit vector, that's just telling me how much direction it's going. For the unit vector, you need the magnitude, 1 over the magnitude. I can explain that in another video if you want me to, but that's just the rule. So it's 1 over the magnitude of this. So 1 unit in that direction. So 201, how do I get the magnitude of that? Well, I just square them and get the square root of 2 squared plus 0 squared plus 1 squared, square root, and that's 5. And that goes there, and that is the unit vector in any direction. Okay, so that's part 1. Part 2 then, hence or otherwise, find one point that is root 5 units from C. So it'd be root 5 times this. which is root 5 over root 5 to 0, 1, which is just 1 to 0, 1. So what would be that from C? Just add it on to C. Where's C? Here. 9, 13, minus 10. And then, so that plus that, we can take it away, it'd be some unit vector, so we give 11, 13, minus 9. That's one example. There's a few you could do twice that distance, 3 times that distance, if you wanted. It's just some vector on the direction. Now, if you're not too sure of the unit vector, go back to that chapter on vectors, have a little look, I'll explain it. If you still need me to explain it, I can do another video on it, so you can ask me about that if you wish. Moving on to question 10, probability and the trigonometry question, which was the most difficult question on the paper, I think. But well within your capabilities. Alright, so given that, so you have your probabilities. So the probabilities, if it was tossing a coin, it would be a half and a half. If it was rolling a dice, it would be 6 and 6 and 6s. And there's 6 of them. They always add up, probabilities always add up to 1. So in this case, looking at that table that you hopefully can see in front of you, cos theta plus 2 cos 2 theta has to be 1. Know that they have to add to 1. Now this looks like trigonometry identity that we have to solve. Can't do much with cos theta, but there is something you can do with cos 2 theta. If I look at my formula booklet, I think that equals 2 cos squared minus 1. Are you right? Yep. So I'm going to just replace that. Why am I doing that? Because I can see that it's going to form a quadratic equation which I can solve. At the moment, can't solve this, so if I change that to sine or one of the sine ones, that's going to be sine and cos, which is going to be difficult. The answer only wants the answer in cos, so I'm just thinking stick to cos and see what happens. And I know that cos squared and cos act like quadratic. So cos theta plus 4 cos squared theta minus 2, and multiply by 2 equals 1. And you can already see that you are getting 4s and 3s, and your answer is 3/4, which is helpful. Rearrange that. Now, so that's a quadratic. Now you could call that x if you want, 4x squared plus x minus 3, because you can just say x is cos theta, and then come back to that at the end, just to make it easier to solve. So if I would do 4x, x, so I want to make 1 in the middle, so maybe 3 here and 1, so that gives me 3x, that's going to be 4x, and I was going to subtract, so this is going to need to be plus and minus. Hopefully you're able to solve quadratics that quickly. If you're not, ask me, I'll go through it again. Remember that these two multiply to give minus 3x, these two multiply to give 4x, subtract, you get positive x, and then solve it to finish. 4x minus 3 equals 0, and x plus 1 equals 0, take them separately. Now, x was cos theta, remember, so you can put it back in. 4 times cos theta equals, bring over, it's 3, so cos theta is 3/4. What about this side, you say? Cos theta is minus 1. That won't work for us because we're dealing with probabilities. Probabilities can't have a probability minus 1. Doesn't make sense. We'd stick that one. Not that we needed to anyway, we found it. So that's worth 6 marks. Part B then is away from probability and into trigonometry fully. Well, this was mostly trigonometry, it's just the very starting in probability. It actually wasn't a probability question. It's definitely a trig question. So that's why I gave some trig to do, to recognize what to do. so tan theta is greater than 0, find tan theta. So you use cos theta. Some angle theta has a cos of 3 over 4, so adjacent hypotenuse. Want to find x over here, so x would be 4 squared, take away 3 squared. X squared is, so the square root of that, and x then equals root 7. So that's now root 7. Awesome. So what's the tan of that? Opposite over adjacent is root 7 over 3. Done. Part C. Okay, so volume, solid, formed, rotated, 360. So there's a formula in your formula booklet which will help you with this. So it's going to be integration. 1 over cos x is y, so that's going to be y squared. From theta to pi over 4, cool. And it's going to be pi times that because it's rotated 360 dx. We want to fix that setup. That's where we formulas. Anytime you see rotation, just come to this. Alright, so the tricky bit of this may be to recognize from your formula booklet that 1 over cos squared x integrates, so I just squared it, integrates to tan x. That's there. The differentiation of tan x is called 1 over cos squared x, so backwards 1 over cos squared x equals tan x. So when you integrate, that is now tan x between pi over 4 and theta. Okay, pi times that, so pi constant can be left out. So that's pi times, so you know to sub in these, tan pi over 4 minus tan theta. Now, tan pi over 4, you can do your table out, and you should recognize 45 degrees would be the same distance over the same distance, which is 1. So do your table out if you're not sure of that, sine cos tan thing. Minus then, well, tan theta, what is tan theta? Well, we have it up here, 7 over 3. And you can tidy that up if you want, or leave it like that, or some sort of thing, and that's the volume. Okay, and that is the answers to our standard level mock paper